Alright, so today we're going to be exploring intermolecular forces in chemistry. The prefix inter meaning between, and molecular forces meaning the forces between molecules. So all compounds have a solid, gaseous, and liquid state, and it all has to do with their intermolecular forces, which determine at what temperature or what amount of energy it takes to switch states of matter. Okay, so this is an example of a question you might be asked on the AP test. So explain why the boiling point of HF, hydrogen fluoride, is higher than that of HCl, hydrogen chloride. So the first step to solving a problem like this is figuring out if the compound is covalently bonded, metallically bonded, or ionically bonded. So we know that HF and HCl are both covalent molecules, as both atoms in the compounds are nonmetals. So the types of intermolecular forces that covalent molecules can experience are hydrogen bonding, dipole-dipole interactions, and London dispersion force. So we know that hydrogen bonding occurs when there is a hydrogen bonded to either a fluorine atom, oxygen atom, or nitrogen atom. So that means that HF is a hydrogen bonding compound. HCl, however, is not. So the only forces that HCl has is London dispersion force, which is relatively weak because HCl's mass is very low. So HF would have stronger intermolecular forces as it is hydrogen bonded, and that gives it a lot more strength in a system of molecules. So now that we know which molecule has higher intermolecular forces, we can determine why the boiling point of hydrogen fluoride is higher than that of hydrogen chloride. So in this model down below, we can see that hydrogen's one electron is taken by the fluorine atom because it's super electronegative and it wants to complete its octet, meaning it would make the atom more stable to have a full 8 electrons. So with this fluorine atom, it is super negative, a lot of electrons, meaning it's very negative. So the hydrogen, being super positive, is attracted to this fluorine and forms a strong intermolecular force. In hydrogen chloride is not electronegative enough to take the full electron. So what happens is the hydrogen is still super positive, just not as positive as that of hydrogen fluoride. So the chloride is still experiencing attraction from the chlorine atom, it's just not as strong because there's not as much polarity. Now we can determine that the boiling point of hydrogen fluoride is higher than that of hydrogen chloride because the forces in between molecules are stronger in hydrogen fluoride and therefore take more energy to turn into a gaseous state, which is what a boiling point is. So when you break these intermolecular forces, you have molecules spread out and not really attracted to each other. So that means that the intermolecular forces are no longer attracting to each other. This model below is meant to show the intermolecular forces between molecules. So in sodium chloride, an ionically bonded compound, sodium gives away an electron to chlorine to fill its octet and therefore make it more stable as an atom, as well as it loses an electron to make its octet full. So as you can see, the fully negative chlorine and the fully positive sodium are attracted in a lattice structure, and this makes it for a very strong intermolecular force. And this is called ionic bonding. So in fluorine 2, we have two fluorines covalently bonded, but neither atom is more electronegative as it's the same atom. So the only forces in a structure that are attracted to each other is this London dispersion force. I like to think of it as a cloud of electrons, and one electron or a group of them happen to be in one area, making it very negative, and the other making it very positive in this instantaneous dipole moment. So this is a very weak attraction unless the molecule is very massive, in which the electrons are more polarizable, meaning the instantaneous dipole is a lot stronger. But in fluorine, the atoms are not massive, so it's a very weak force. So to get back to the question at hand, F2 would have a greater vapor pressure because the weak intermolecular forces allow more of the compound to escape when it's heated. So there's more pressure or more compound in one space at a time. When heating sodium chloride, there's going to be less vapor pressure because the bonds are strongly held together and there won't be as much of the compound turning into a gaseous state because the strong bonds keep it in a solid. Thank you so much for watching this video, and I hope I helped you gain a better understanding of concepts in chemistry.